All right, guys, so I need to take you back to a time of 1920. That's probably before the majority of us were born, but I need to take you back to that year because this was a very special year in terms of laboratory technique and laboratory methods that happened in the laboratory. And this lab exercise is going to concern the Dean Stark apparatus. And before I talk about the Dean Stark and before I show you a depiction of a Dean Stark apparatus, we need to talk about basically what led up to this point. Why do we need something like this in the first place? So 1920s is where you're going to find that happen for the very first time. And the reason is because here petroleum was booming. So if you've taken a look at the ID of an unknown hydrocarbon lab, we've talked about petroleum there. If you've watched the fractionation lab, we've probably talked about fractionating pieces of crude oil and having them come off in bits and pieces. But here, the problem was petroleum. And the reason that I say the problem is because it wasn't the petroleum that was a problem. It was the contamination that was the problem. And we needed to get rid of contamination, right? We don't want any of the trash that's left behind. So how do we get rid of it? Well, first we've got to know what this contamination is. And this contaminant was nothing more than water. So how on earth can I separate water from the petroleum so that way I can give you a pure petroleum product that you can then use for other purposes? I mean, think of this, for instance, as putting gasoline in your car. Let's say that you go to the gas station, you put gasoline in the car, and it's pure gasoline. It goes straight into your tank, everything's good to go. But then let's say that that gasoline sample has water contamination. What happens when you put water in your gas tank? So you can kind of imagine why this was such a big deal back in the day, because we had to get the water away. Now, the problem here is that a lot of people said, well, we'll just heat it. Right? If we heat it, then all of the petroleum could maybe distill over and we could capture the petroleum, and maybe we could separate the boiling point of water out and collect the water and remove it, and then just continue to heat the sample from that point to get all of the higher boiling point petroleum compounds as well. Well, here's the problem. If you heat it, this does not work. And the reason is because the problem is with emulsions. We got to talk about what an emulsion is. So an emulsion is basically a slurry. It's a slurry of oil and water, or what we would call a polar and non-polar substance. And the way that I want you to think about this is Italian salad dressing. Okay? If you go to the grocery store and you look at Italian salad dressing bottle, you're going to see, if it's been on the shelf for a while, a separation, right? And that separation is going to divide your oil from your vinegar part, right? Your polar versus your non-polar material. Well, in the Italian salad dressing, you're probably going to look really close, and the area where the vinegar meets the oil, the aqueous part meets the non-aqueous part, you'll see a fuzzy, hazy little layer that will look very cloudy. That's what we call an emulsion. And an emulsion also happens in separatory funnels. So let's say that you take the separatory funnel and you put two solutions in and you give it a good shake. Well, if you give it too much of a shake and you agitate it too much, you might mix them a little bit too well. And when you do that, an emulsion or a cloudy layer will form at the interface of the two liquids. So in a separatory funnel, I'm just going to draw kind of an example of one up here at the top. And in the separatory funnel, you've got two layers. You've got one layer on the top, and you've got one layer that's down here toward the bottom. Well, the emulsion would be the interface, and it's the interface of the two liquids. And this becomes very cloudy, and this becomes a problem when it concerns separation. And petroleum and water does this. So we needed something that was very quick, and we needed something that was very easy to separate these two things from each other. And people sit around the laboratory and they scratch their head, And finally, we get a white paper. And a white paper is basically a research paper. That's all that it is. So 2 guys in a laboratory. The guy's name was E.W. Dean and D.D. Stark. Paired up together, not Stark Industries, by the way, if you're an Iron Man or a Marvel comic fan. But E.W. Dean and D.D. Stark sat around a laboratory, and they basically came up with a way that they could separate this water from a sample. And this process never really had been done before, or at least hadn't been published before. Whoever makes it to the publishing route first wins the prize, right? So Dean and Stark came together to publish this paper. Okay, so what did the paper say? Well, let's take a look at it. I've got a picture of it right here. So I'm going to enlarge this up, and I'll show you basically this article that was written back in the day. So it says, a convenient method for the determination of water in petroleum and other organic emulsions. E.W. Dean and D.D. Stark, Chemical Section, Petroleum Division, U.S. Bureau of Mines. Received January the 15th, 1920. And it says, one of the problems frequently confronting the petroleum chemist is the determination of emulsified water. Numerous methods have been devised, several of which have been described in a previous publication issued by the Bureau of Mines. Allen and Jacobs discussed that in the paper the advantages and limitations of various types of procedure and recommend as the most desirable the scheme of distilling in a special electrically heated still. This type of still involves heating the entire outer surface at 250 distilling flask, and its use permits the breaking of troublesome froth that is usually formed when a viscous petroleum emulsion is heated. So on through the article, it's going to say, well, we've came up with a different way of doing this. We know that you've attempted, but we think that we maybe have come up with a solution. And that was called the Dean-Stark apparatus. And that's what you're going to be using in this laboratory. And that's your advanced lab technique method for this laboratory as well. So again, if we want to talk about emulsion, here's water, right? And then here's water and oil, and they separate. And that's what you want to see. You want to see these solutions separate in a laboratory environment. You don't want them to see kind of hanging out with each other. You don't want to see problems like emulsions that begin to form. But here is mustard. And mustard is an emulsifier, which means that it can take that water and it can take that oil, and mustard is able to bring those two people together and sit down at the same table and talk about deals, right? So here you get some mustard that is an emulsifier. It's taken these two samples and it's completely changed the chemistry with them. And now those two liquid layers are together as one. Now, how would you separate the water from mustard? That's the question, right? This is sometimes the difficult part to answer. And that's what this lab, and that's what the Dean-Stark is basically going to help fix. So let's take a look at the depiction of a Dean-Stark apparatus. So over here to the right-hand side, you're going to see a Dean-Stark apparatus, and down here at the bottom is a bowling flask. So spot number 1 and spot number 2. Spot number 1 is probably going to be your sample, and then spot number 2 is a bowling flask that you're going to sit down there below using a variac transformer. All right, so you're going to heat this stuff up. And when you heat this up, just like before, when you heated anything up, if you've done previous labs, well, that vapor is going to rise and go up. And that vapor will go into what we would call maybe a fractionating column or some kind of neck at least. And in this picture, what you'll see is a thermometer right up here at the very top. We like to control the temperature of it. This tells us what temperature the vapors are, so we know what's coming over. Sometimes the thermometers are used, sometimes they're not. But, you know, in this picture, they're using a thermometer. Their Dean-Stark allows that to happen. And then this vapor will go up the neck, and then it will travel over to the other side into this, what looks like a graduated cylinder, right? It's got some markings on it like a graduated cylinder, but then down here below, it's got this tip and a stopcock. So this almost looks like a burette now instead of a graduated cylinder. right? It looks like a burette more than it does anything. Well, there's an issue here. There's something that's going on here that we need to talk about and that we need to focus on. And I'll talk about that in just a second. But if the vapor continues to go up, what you'll see is that it will go up into the condenser. And just like all the other condensers, water goes in from the bottom and it goes out of the top, all right? So this condenser is no different, but the purpose of the condenser is to condense. Go figure, right? So the vapors go up this condenser, and the cold temperature of that water will turn that vapor back into a liquid, and it will drip down into this burette-looking thing over on the right-hand side. Now, this is the Dean Stark apparatus. So this is all the glassware assembled together. But the real Dean Stark piece, if you had to order the Dean Stark apparatus, you would be ordering this little piece that looks like a burette with this small piece of glassware that comes over to the left with the neck here. That's what you would be ordering. That's what really makes it a Dean Stark apparatus. Now, with that said, there's plenty of other ways that a Dean Stark apparatus can be made. This is just one of them, and I've got some pictures of some others that we'll take a look in a minute. But on a final exam or on a quiz, be familiar with the Dean Stark setup, just like you're familiar with all the other glassware apparatus, right, that we've talked about during the semester. So if I give you this diagram or this picture, be able to label these pieces. So number 1 is your sample. Number 2 is the boiling flask. Number 3 is the Dean Stark apparatus. That's the actual piece that makes this a Dean Stark, okay? Number 8, which is, or if we go in order, number 4 is the thermometer. Number 5 is the condenser. 6 is where the water goes in, and 7 is the water goes out, always from the bottom and out the top. And then finally, number 8 is the graduated collection tube. So this is going to allow us to record volume of a liquid. And then number 9 in this depiction is a stopcock that allows you to drain stuff off if you need to drain things off. And number 10 over here is the collection valve. So this Dean Stark apparatus uses number 9 and number 10, and some versions do not. The rest of it they use, but number 9 and number 10 can sometimes be missing. So if I take a look at real pictures, what do these things look like? Well, here to the left is a Dean Stark apparatus. Notice that this one has no neck for a thermometer, all right? So over here to the right-hand side of that picture, this is where your boiling flask with sample would be attached to. And the vapor would rise up, and it would go up this neck, and it would transfer over to the left-hand side, and this is your pointed area that looks like a burette there. So that burette-looking piece is what makes this very special, and that's your Dean Stark apparatus, right? This whole thing. So it doesn't have a stopcock, you can't drain anything off of it, and there's no collection flask that sits down below because you can't drain anything off of it. Okay, so that's a more simplified version of a Dean Stark, and this is actually what we will use in our own laboratory. We do not use the ones with the stopcock and the receiving flask. We use these that you're seeing on the left-hand side. In the middle, this is another diagram of a Dean Stark apparatus. There's no difference here, except there's no part for a thermometer, so big deal, right? And then over here to the left, there's not a stopcock and receiving flask. So this is the simplified version of a Dean Stark apparatus that you might see versus the diagram that you see on the right-hand side of the screen, which does include the stopcock and the receiving flask basically that would sit down below. So there's your Dean Stark lesson for glassware at least. Now, we want to talk a little bit more about this laboratory procedure. Why is it important? What will we actually be doing with it and so forth, right? So what we'll do is that we'll talk about that in the upcoming video. So what's coming up next is what are we going to be Dean Starking? Why do we need to Dean Stark it? And maybe some statistics and background information as well. So stay tuned. Come back and see me.